In artificial intelligence and machine learning, concept of overfitting, underfitting is the fourth topic in the third unit. Overfitting refers to a scenario when the model tries to cover all the data points present in the given dataset. The model starts catching noise and inaccurate values present in the dataset. Because of that, it reduces the efficiency and also the accuracy of the model is also get reduced. The overfitted model has low bias and high variance. The overfitted is represented in like this. The reasons for overfitting in machine learning are noisy, that is garbage values in the training data, high variance in the model, the complex models, not using a resampling technique. These are the reasons for overfitting in machine learning. The performance of the overfitted model, the accuracy score is good and high during training, but it decreases during testing. What are the different ways to avoid overfitting means by means of using cross validation, using regularization techniques, implementing ensampling techniques, picking a less parameterized or complex model, training the model with sufficient data, then removing features, early stopping the training. Underfitting in machine learning. Underfitting is just opposite to that of the overfitting. Underfitting occurs when our machine learning model is not able to capture the underlying trend of the data. An underfitted model has a high bias and low variance. Reasons for underfitting. Noisy garbage values in training data, high bias in the model, less training the data, the model is too simple. These are the reasons for underfitting in machine learning. The underfitted model performance is represented like that. The accuracy score is low during training as well as testing. What are the ways to avoid underfitting means pre-processing the data to reduce noise in data, noise training to the model, increasing the number of features in the dataset, increasing the model complexity, increasing the training time of the model to get better results. Good fit model in machine learning. Good fit model is a balanced model which is not suffering from underfitting and overfitting. This is a perfect model which gives good accuracy score during training and equally perform well during testing. Detecting overfitting and underfitting as well as good fit. Classification. These are the examples for classification and regression. In classification, the first image represents overfitting. It is good fit. The third one represents underfitting. In overfitting, training error is low, testing error is high. In right fit, both the errors are low. In underfitting, both the errors are high. Comparison between overfitting and underfitting versus good fit model. This diagram represents the comparison between the overfitting and underfitting. Ridge regression. It is another type of regression in machine learning and is usually used when there is a high correlation between the parameters. Another type of regression is lasso regression. Lasso regression performs regularization along with feature selection. It avoids the absolute size of the regression coefficient. The results in the coefficient value getting nearer to zero. This property is different from what the ridge regression. Bayesian linear regression used to find out the value of regression coefficient. In Bayesian linear regression, the posterior distribution of the feature is determined instead of finding the least squares. Decision tree regression. The decision tree, as the name suggests, the principle of conditions, it is efficient and has strong algorithm used for predictive analysis. It has mainly attributed that include internal modes, branches, and a terminal node. Random forest regression. Random forest comprises an enormous amount of individual decision trees that work as a group or, as they say, an ensemble. Every individual decision tree in the random forest lets out a class prediction, and the class with the most votes is considered as a model's prediction.